Right. We have an application problem on the mass spring system. So we're going to have this equation, and in particular case we have the mass, the damping factor, and the spring constant, and the initial conditions. We're going to put all of that together into the equation, and we have initial value problem. Solving that initial value problem, we have the equation for the motion, for equation of motion. Right. I'm going to do that on the next page because this will take a lot of space. Right. So first the equation, the mass is 20 kilogram. So we have 20 second derivative plus 120 times the derivative plus 260 times the function equal to the first part is just equal to 0. So no external forces. And we have initial position at 0.2, and the derivative, which is the initial velocity, is negative 0.4 meter per second. So that's that. So we have this system, initial value problem. So we will solve for that. It is homogeneous equation. So we just have the auxiliary equation. By the way, I will divide everything by 20, but we'll do that later. 20r squared plus 120 r plus 260 equal to 0. Divide everything by by 20. You have r squared plus 6r plus 13 equal to 0. Right. It does not come out nice and even, so we have to use quadratic formula. Negative 6 plus or minus 6 squared minus 4 times 1 times 13 divided by 2 times 1. 36 minus 52, so that's negative 16. Over 2 minus 6 plus or minus I is imaginary, and square of 16 is 4, so we're going to have 4i. Divided by 2. All of them are even, so I reduce the top by 2. So negative 3 plus or minus 2i. Right. It is a complex solution, so we have y1 equal to e to negative 3t cosine of 2t, and y2 e to negative 3t sine of 2t. This is the first part of the question. All right. So the linear combination is the solution, and we have y equal to c1 e to negative 3t cosine of 2t plus c2 e negative 3t sine of 2t. And so that is the general solution. Now we will have the initial condition. Y0 equal to 0.2. So I'm going to put 0 into the function for t of the function. And to that we have a lot of 0. E to 0 power is 1. Cosine of 0 is 1. E to 0 power is 1. Sine of 0 is 0. So all the, but before we do anything, the function is equal to 0.2. So we make that equal to 0.2. And everything clear, we will have C1 is equal to 0.2. Right. Next, we have the derivative is equal to negative 0.4. Right. We don't have the derivative yet, but we have the function. So from this function, we take derivative. Take derivative first and worry about the values of t later. Right. Now we check the derivative of this function here. Alright, that is the product rule. It's going to be a bit long, but say C1 derivative. So it will be negative 3 C1 e to negative 3t cosine 2t, and then plus derivative of cosine is negative, so actually that's going to be negative 2 C2 e C1 e to negative 3t. Derivative of cosine is sine 2t. And now on to the second term. It's going to be negative negative C2, negative 3 C2 e to negative 3t sine of 2t, and then plus our derivative of sine is positive cosine, so we have 2c2 e to negative 3t. Derivative of sine is cosine of 2t. Right. Now we're going to put 0 on for t. Notice that when 0 equal to t, sine of 2t is going to be equal to 0. Sine of 0 is 0. So that term cancel out. And this also equal to 0. Because sine of 0 is equal to 0 when t equal to 0. So we don't have those terms just equal to 0 at t equal to 0. And then when t equal to 0, cosine here is going to be equal to 1. E to 0 is equal to 1. That equal to 1 and 1. So we put everything back. The derivative is negative 0.4. We have negative 3. C1 we do know is 0.2. And then minus, actually plus 2. C2 we don't know the values. So from here we can find the values of C2. So I move the negative 3 times 0.2 to the other side, that is 0.6. So plus 0.6 on both sides. And so we have 0.6, 0.2 equal to 2C2. So C2 is 0.1. Right. And with that, we have the equation for the motion. Zero point 0.2 e to negative 3t cosine 2t plus 0.1 e to negative 3t sine of 2t. Right? So that is the first part of the question. The second part of the equation, the question is that find the equilibrium So this is just an algebra problem. Sorry. Yeah. So based on this equation, now we will solve the algebra problem. So I'm going to go to the next page for that solution. First, let's copy the equation. So we're going to have this equation. And the set where is the equilibrium. The second part is time equal to what when equilibrium meaning y equal to 0. So pretty much we will let this equal to 0. This actually is easier than it looks. So we have 0 equal to 0 0.2 e to negative 3t cosine 2t plus 0 0.1 e to negative 3t sine 2t. Right. First of all, we notice that e to negative 3t is not going to be 0. Actually, it's going to be positive because exponential function go like this. Except when t go to negative infinity, then that will be 0. But we don't have it. So with that in mind, we will do this. Let's move the cosine to the other side. So I minus the cosine on both sides. So do that, and we will have sine of 0 0.1 e to negative 3t sine of 2t equal to negative 0 0.2 e to negative 3t cosine 2t. Right. Now, because e to the negative 3t is positive, it's not going to be 0. So if I divide that on both sides, the equation will still true. And then I will also divide by cosine of 2t. And try to eliminate the 0 0.1, so I will divide by the 0 0.1 as well. So when everything clear, we should have just tangent of 2t equal to negative 0. Negative 2. Because sine over cosine is tangent. Now this is very easy now. Tangent equal to 0, tangent equal to negative 2t. So we say 2t equal to tangent inverse of negative 2. Notice that this is the first time it happens. So we just let that equal to 0. We're going to use the calculator for this one. Tangent of negative 2. Make sure that it has to be in the radian mode. So it is in the radian mode. Tangent inverse of negative 2. So I have 2t equal to negative 1.107. Obviously, it's not going to work with the negative time. So I have to add a 2 pi to it to make it positive. So that approximately equal to 5.17 something. sorry, it's not 2 pi, it's just a pi, because a period of tangent is a pi. We have negative 1 point something here, and so just add a pi to it. Sorry, it's not 2 pi. So a period of tangent is just a pi. So we have 2.0344 something. Divide that by 2, we have t 1.017. That's good enough. Second. Right. Next question is just about the physics, asking what is the frequency for this. So we look at this function. Of course, we can combine this into something here, sine of 2 pi 2t plus something here. That will be the phase shift, and we do that. But we don't need to have that or this. We just focus on the two. Notice that period for sine, cosine is 2 pi. So we have the sine has period of 2 pi. So sine of something 2, we divide that by 2. So the period for this problem is 2 pi divided by 2. It's going to be a pi. And then the frequency is the reciprocal to that. It's going to be 1 over pi. Frequency is the reciprocal of the period. 1 divided by pi is 0.318. Right. And that. Of course, the unit is going to be the cycles per minute. Right. Next. The next part of the question, I will go back to the first page. The corresponding undamped system has the frequency of this, which is higher than the numbers we have. So we say that the damping will significantly decrease the frequency because of the friction, the damping that will actually also decrease the magnitude over time. And of course that's reasonable because the friction will generate heat and will take the energy away from the system. But the math part is, of course, we solve the initial value problem, and from that initial value problem, we find where the time where y equal to 0, which is the equilibrium, and then we find the frequency, and that is this problem.